All right, welcome back. We're looking at question 7. It says the figure below illustrates two sampling distributions for sample proportions when the population proportion is p equals 0.50-50%. So right away I noticed, this clue, right? We're looking at sampling distributions for sample proportions. Okay. And when I look at these two density curves, right, I notice that distribution 1 is very narrow, right, so it has very little spread, and distribution 2 is very wide, so it has a lot of spread. Okay. So that's a clue that we need to, be looking at something related to perhaps the standard deviation, right, or the spread of the sampling distribution for sample proportions. So I went to the formula sheet and I found these two formulas, right? So the first one is about the mean of sample proportions, right? So they should kind of center or cluster around the true proportion. But it's the second formula here that has to do with the spread or the standard deviation of a bunch of sample proportions, right? And that standard deviation or spread is represented by this expression. Okay. Now the problem tells us that the population proportion is 0.50, so we're going to have 50% here, 1 minus 50% there. But the problem doesn't tell us anything about the sample size. And we see that that sample size shows up in the denominator in the expression, right? So, simple algebra, right? We know that when values in the denominator increase, the overall expression gets smaller, right? That's why 1/4 is a smaller value than 1/2, right? Because 4 is the bigger denominator than 2. Okay? So, since distribution 1 is narrower, we can conclude that it has a smaller standard deviation. And because it has a smaller standard deviation, that would also imply that its sample size must have been larger. Okay. So now looking at the choices, the very first one says the sample size of distribution 1 is greater than the sample size of distribution 2, right? That would be correct.